So are you able to see the screen?
Yes, sir.
Okay. Good morning, students. So as we discussed in Saturday class regarding laboratory sessions, so we have done with third program. So drawing a color cube and spin it using an OpenGL transformation matrices. So that we have finished by learning the concept of projection. So projection is nothing but transformation of 3D object into a two-dimensional object, or in two-dimensional space you are going to project. So that is about projection, and we have two different types of projection: a parallel projection or orthographic projection we can call, and perspective projection. And we have seen a couple of differences between these two projections. So basically two difference we have highlighted. So one is with respect to the how the projection lines are moving. So that is parallel or not parallel. And what about the center of projection or the reference point? So whether it is finite or infinite. So these few points we have discussed about the projection types, and we have deal with the third program, and how the cube is spinning, and how the cube is constructed by considering all the 8 vertices, and the color combinations of your RGB and CMY color models. And it has 6 faces, and we have seen the faces also by specifying the points or the vertices values like A, B, C, D, whatever we have considered the parameters for our color cube function. Okay, so that we have seen already. So next, same way as I said, just only one or two points different from the third program. So your fourth program will be draw a color cube. Again, same thing you have to draw, and allow the user to move the camera suitably to experiment with perspective viewing. So here in this case, what changes we are observing? So object is not moving. Object will be constant. Means it is not, there is no movement for the object. The user has to move the camera in a different direction, and he has to observe, or he has to view the object how it is spinning. So that is what. So object will be static and your camera is moving. Okay, this is what the allow the user to move the camera means nothing but your camera or your eye coordinate system suitably to experiment with perspective viewing. How you can able to see, because you have to change the position. So now suppose there is an object you assume at some particular distance. So there is a tree. So I am standing 3 feet away from the tree, or my camera is placed 3 feet away from the tree, suppose initially. Now I am changing for the second time, I am changing the direction of the camera or the distance. Obviously the distance will be changing and the position is also be changing. So now I will move my camera like another suppose 10 meters away from the tree and in a different direction. Okay, so like that you have to perform a different possibilities how you are going to view an object in case of perspective viewing by moving the camera. That is what the fourth program. In this, what output you can expect. So just initially you can, when you are executing your program, you can able to see that cube on the screen. Just previously in third program, when you are executing your program, your cube is started spinning with some certain speed. So when you are trying to interface using the mouse, either pressing the left button, right button or center button, your cube is changing the position, like spinning. Spinning is same, it's the speed, but the position it is going to change with respect to x axis or y axis or z axis. Like that we have observed. But in case of fourth program, so what we have to do, so just when you are start executing the program, so then you are just, there is a constant cube you can, because the object is constant as I said, so there is no movement initially. So as your camera is going to move, that is again I'm telling. So in this case we are using keyboard interface also along with the mouse interface. So constant object you can able to see over the screen. So there is no spinning initially. You have to either using the keyboard or mouse, you have to start spinning the cube. That is what the difference. So when you saw the output, you will get the clear picture. What is the difference output we are getting in third and fourth program. Okay, this is what the simple difference between third and fourth program. So we'll go back to the program again. Same thing. There is no much difference in that. So let's see. Just again. So go to the starting library. If you study that program, this also same thing. There is a slight change in the code. That's it. You can ready for two programs for the exam as well. So just same thing, a question written again, GLUT library. So as I said, these are for the vertices. You are going to consider 8 vertices. And similarly, I showed in the last program execution that the whatever the vertices are there, no, they are filled with some solid color. Okay, so those are these colors. So for which vertex, what is the color combination I'm going to choose? So that is about your vertices and the corresponding color formation. Next again, as we discussed, that is the theta. So that we are considering with respect to the origin. That's why initially it will be the theta value means for XYZ axis it will be 0, 0.0 because it is reside at the center or at the origin. And axis 2. So that is we are considering the speed of that. So in how much the speed the cube is going to be. More function, that is a view where the viewer will be the initial viewer location, nothing but camera location, as I said, right? So suppose I'm considering 3 feet or 3 meters away from the object, nothing but the tree. So that is what you have to specify here. So initially they have already clearly specified where initially the camera will be set up. So you can change the value. There is not a fixed value, you can change the value. So this is what the initial viewer location are. Just a second. So that's over. Declaration part is over. Next we'll go to the main function. Same thing. Void main. So again, character like argument character type and argument vector we are using. So this is just to establish the connection between your command prompt and the OpenGL function. And again, GLUT display mode function, GLUT double RGB and depth information you're going to enable it. And window size you're going to specify 500 500, that is width, height, W and H. And GLUT create window, again color cube viewer, just you give the name whatever you want. And now we'll move on to the GLUT reshape function. So same thing, whatever we have seen in the third program, same only I'm going to use the my reshape function. Again, W and H I'm going to pass. Same viewport. So where I'm going to visualize my object, that is the we have specified width and height. So here you can change the values according to the this calculation. Okay, but in the previous case we have used GL Ortho, but here we are using GL Frustum. This is what the difference we are using. Different function we are going to use in order to calculate. So previously GL Ortho, you can remember. Okay, so but here we are using GL Frustum. I will go to the GL Frustum and tell you. So what is that? So that is the one difference you have to remember. So in the previous case, my reshape function we use GL Ortho. That's it. Same H divided by W. If suppose this condition fails, again else part will be W divided by H. Okay, and again we have two matrix calculation. One is so matrix mode GL projection, and again GL matrix mode model view. So all the changes whatever we made, those values are going to be saved in the matrix. So in the form of matrix GL model view. Okay, so this GL frustum I will show here. So this is an OpenGL function we are going to use for perspective viewing. So what it will describe. So the GL-Frustum describes a perspective matrix. So as we said, so we are using for perspective viewing for the sake of perspective viewing. So obviously it is going to describe the perspective matrix that produces the perspective projection is the current matrix is multiplied by this matrix. Current matrix means what? The whatever the object I am going to observe, I am going to see the tree, whatever we have considered. So that matrix value, current matrix of that object, you have to multiply it by this perspective matrix, and the result replaces the current matrix. Means you have to do the cross product of your perspective matrix with the current matrix of the object. So the whatever the product or you are going to get resultant matrix, so now that will be pointing to the current matrix. Okay, so the function will be like this. So few values we have passed 6 parameters for this function. So first is x minimum and y minimum value, x max and x minimum, x max, y minimum, y max, and near and far. So this near and far we have seen. So in case of perspective and perspective view or parallel view, we have the concept of near and far. Obviously, so suppose there is an object and we are positioning we are placing the camera. So there may be changes, right? So it will not be fixed whether you can able to view the object nearer to you, nearer to the camera, or far away from the camera. So there are two concepts. That is, again, we are measuring with respect to distance only, how far it is and how near it is for the camera. So that object is nearer to the camera or the I coordinate system, or far away from the camera or I coordinate system. So there is a fifth and sixth parameter we are using. Anyway, we have already know that x min and y min, x max and y max value. So same thing, just this is the reference point we are considering for x and y z axis. Okay, so just you assuming. So this is the outer screen, the whatever we are able to see, and this is the back portion. So this will be the front and this will be the back face, and we have the value. So diagonal opposite elements are our vertices we are considering, and this will be like this portion having the z value because we are projecting along with the z axis. Look at this. So the projection lines, whatever you can able to see, these 4 projection lines are moving towards an z axis. So that's why, and all these coordinates are, all these projection lines are meet at the origin. This is the COP, center of projection. Okay, so that will be 0, 0, 0. So this is the origin or center of the COP. We said no. In case of perspective viewing, it is some having distance, finite distance, and all the project lines will be meet at one point. That is what a COP, center of projection. So here just you can observe. So these are the 4 different projection lines for this case, and these will be meet at this particular point. And we have considered these two values for that. Just one is like x min and y min, and with the minus, because z axis we are going in the opposite, no, so negative value, minus near, and this will be far because this is very closer to that COP. So that's why it is nearer when you are observing from here. So this will be the near value and this will be the far value. So that's why minus near, minus far, and obviously x min, y min, and x max, y max value we are going to consider. So this is how you are going to pass the values for this GL-Frustum function. So this is about GL-Frustum, and we'll go back to the program. So same thing we have considered here. This is x min, x max, so like that. Those values, these are whatever, along with the width and height, whatever we are passing, that is 500, 500. So we are going to calculate based on that. And this object, your object is going to be reshaped. And we are storing all those values in this matrix format. So this is about your wide myReshape function. So this is over. So now control will come back to the main function. Again, let display func display. So we'll go back to display function. Yes. So wide display wide. So yeah, same thing again, same only. So all are repeating. This code is also same. There is no change in that. So only this, whatever I showed in the previous function, that is the one change you have to remember, and this is same as like previous one. So just again color buffer bit and depth buffer bit, you are going to update the viewer position in the model view matrix. So all the values, so new values, updated values, you are going to put it in a whatever we have put it in model view matrix, right? Just you are going to clear that and you are going to redefine again. So for the next step. And again GL load identity. So just to erase the current matrix information, you're using GL load identity. And this is the one new function we are using, glue lookat. So this is one more function. So you have to remember. So this function also we didn't use in the previous program, and GL frustum and glue lookat. So these are the two changes we are using. We are considering in case of fourth program. All right. One is GL frustum and glue, that is what GLU lookat. Okay. So then what is this function? So what are these input values we are passing? Something like viewer 0, viewer 1, viewer 2, and some values 0, 0.0, 0.0 like this, right? So what this function, what are the inputs these we are passing for this function? Okay, so we'll go to that function. So this is over. Yes, this is about your glue lookat function. Okay, so what this glue lookat function will define? So it defines a viewing transformation. So how the transformation is going to be happen. So that is what the glue lookat function basically referring. So again, in depth, what that means, what are the parameters we are considering for the, in case of, if for the sake of that transformation means we have like this. So like we have different parameters we are passing for this. I think around 8 parameters we are passing for this function. Okay. So this glue lookat creates a viewing matrix. So derived from an eye point and a reference point indicating that center of the scene. So nothing but that COP and an up vector. So here there are three concepts. There are three set of inputs we are passing or parameters. One is eye point and another one is reference point, nothing but COP, and the last one is up vector. So these are the three set of values we are passing to the my GL lookat function. And that is what same thing here using Ix, Iy, Iz, because the XYZ axis we are considering. That's why similarly for at means this one. So reference point, for that we are mentioning at X, at Y, at Z. Next is up vector, up X, up Y, up Z. Total 3 plus 3 plus 3, total 9. So 9 input values we are passing for this. And what is this and how we can visualize through a pictorially. Okay, like this. So this is an X axis, again same thing, Y axis, Z axis. Okay. So now this is the camera. Okay, and this is the projection plane, whatever the cube we are draw the cube, right? That is the so that cube we are going to consider. And there is some reference point here, that is projection. So look at this, there is an object inside this cube. So through the camera I'm going to observe this. Means at some particular distance you can able to see the camera is located at this particular point, you assume. So this only you can able to change to the any location with respect to either Z axis or X axis, Y axis. You have to suitably move the camera. Okay, so that the viewing that whatever you are viewing the object, that will also vary accordingly. Okay, so and that means distance will be changing and faces also it will be changing. So this is the reference point with respect to this. Suppose if the camera is placed here and object is at some distance, and this is what at X, at Y, at Z. So what is specifying? Specifies the position of the reference point. Okay, means nothing but center of projection. So what is the distance from here to here? Either this is a person standing in front of this object. You can refer your eye as a, so person eye is acting as a camera, or you can put direct camera only. So anything is okay. So that is what, that's why eye coordinate system or camera coordinate system we are telling. So this is what the center of the projection. Okay, we can able to visualize the object. So those values you are going to pass, that is at X, Y, Z, the reference points or center of projection points. And next is eye coordinate system. So through my eyes, how I am able to visualize this object or this particular cube, that is Ix, Iy, Iz. So what it specifies the position of the eye point or the camera, specifies the position of the camera or eye point. So this is that point. And up X, up Y, up Z. So what is this up vector? So it specifies the direction of the up vector. So what is that up vector? So it will specify the up direction of the camera. So when you're going to view the object, so there is the concept of up vector. So there is one project line is moving towards up. Okay, so those values, what are those values at particular point or particular visualization. So those values also we are going to consider in case of glue lookup function, okay, or GL lookup function. So the up vector is used to create a cross product between your I coordinate system and the at coordinate system. At or center of projection. So this will be the cross product of these two, at function and I function. So that is about your up vector. So this is how we are going to consider the three set of parameters in case of GL lookup function for the perspective viewing. So that is about your glue lookup function and corresponding the values we are passing here. So viewer 0, viewer 1, viewer 2 and the values. So few values 0 and few value will be 1. That is based on the, so whatever the distance we have considered in that function. Okay. So next is rotate function for all the three different axes. That is x axis, y axis and z axis, and followed by the coordinate values x, y, z. So what are those? X0, y0, z0 and x1, y1, z1. Next x2, y2, z2, like that. So we are going to use the three rotate function for the all the three axes. And now we'll move on to the color cube function. So color cube function is going to call here. So where is that color cube? Yes. So this is the simple color cube construction. That's it. So whatever we have seen in the yesterday's class. So this cube. Okay. So same thing. Whatever we have seen, similar way. So same values only. Again, I am going to use in order to create a cube or draw a cube. And this is indicates which direction and all those things. So in simple, as yesterday I said, you remember these 6 faces: front, back, top, bottom, left, right. So these are the 6 faces of the cube. That is what they have specified in a different clockwise and counterclockwise direction. That's it. You no need to, and this no need to by heart this values. Okay, if you know this cube, you practice this cube and assign these values, vertices values, and remember what are this combination, and aramse you can identify the faces. So you no need to by heart these values. So if you misplace any of these values instead of a different value 4, 5, 6, 7, if you pass some other value, you will not get the exact cube like this. Your cube shape will be changing because it is referencing different coordinate system. Obviously, your cube size shape, whatever we are using, it will not be in the proper format. Okay, that's why don't by heart these values. Just you remember this diagram. It will helpful for both the programs. So and even for theory exam also. So just you have to draw accordingly what are all possible 6 faces. Okay. So that is about drawing a color cube using the color cube function with 6 faces and 8 vertices. So once that color cube function done, again that's it. So it will draw all the possible objects whatever we have gone through till now. And swap peppers, as I said, this is for swapping the faces. So when those current values it is going to store, and it will accordingly it will behave. Suppose now it is a, suppose if you're spinning with respect to x-axis, your face will be different. Suppose front face will be changing to back face or top or left based on the either pressing left button or right button. So those faces will be changing. So by keep on interfacing with the keyboard or mouse. So those change in the faces values in a different move or different spin. So because of that, we have to use swap buffers to in order to store those values. So that's why we can able to visualize all the changes whatever we are observing in the output. So that is about swap buffer function. And once that is done, again control will go to the main function. So now display function is over. So next mouse function. So see this same. There is no change in the mouse function. So that's it. We are using button, state and XY value. So that's what. See, if suppose glut left button you are pressing and state is equal to glut down. So then you are assigning to X axis and Y axis and Z axis. Same thing. So left button, middle button, right button. Okay. And this speed you can change here. So instead of 2, if you change 3, 4, 5 or 1, something like that. So value will be according to change. And again the spinning will be takes place in with respect to 360 degree. So it will be completely in all the angle it will be rotating, and your display function is going to call. So display means that whatever we have seen here. Yeah, same thing. So that's here, this spinning function. So next mouse. So mouse is over, right? Now keyboard. So this is one difference. So in the previous case, we didn't interface the keyboard function. So now we are considering this is one additional function in this case. So what is this keyboard function? So how it will be, how we are going to interface in key. So this is keys, unsigned character key and int xy value we are taking. So now simple. So I'm going to, as we're using mouse, how we are using left button, right button and middle button. But in case of keyboard, I am assigning the values. Like suppose if small letter x means, so it will be going means like zoom in, zoom out. You remember minus means it's keep on. Suppose if you are pressing a small letter x, okay, when you are going to visualize the cube on the screen, if you press small x, it will go inside. Means like volume is going to shrink and your object is going like inside, like zoom in. So next, suppose if you press capital letter X, then it will be come back to its original position. Okay, that is what here. If key is equal to small letter x, viewer of 0, that means with respect to x axis, that is it is going in a negative values, minus symbol is there. Similarly, capital letter X means it will come back to again original position. So zoom out, zoom in, zoom out. That will be taken place with respect to x, y, z axis. So same thing, small letter x, capital letter X. Small letter x means, so zoom in. Next, zoom out. Similarly, small letter y, this is with respect to y axis. Again, zoom in, zoom out. Small letter z, again viewer of 2. So again, zoom in. Next, zoom out. That's it. For all the x, y, z axis, I'm going to consider plus value, minus value. Zoom in, zoom out. I will show how, what is the difference, how we are going to view the screen. Just display function. So it will display whatever the changes we are doing here by pressing capital X or small letter X or Y, Z. So we are going to display that on the screen. Okay. So that is about your keyboard function. Next, last two are as usual, the GL enable. It is going to enable the depth information. So in order to show the invisible faces of the cube, and again let main loop, just all the things, all the functions will be carried out with the help of your main loop function. So this is, then that will be end of the program. So here only three difference you have to remember. One is the usage of GL frustum in case of GL ortho, and we have used the concept of GL lookat function, and these two functions newly added, and keyboard function we have included. So this is the one extra function we have included. Only these three differences we have observed with respect to the third program. Okay. So now I will go to this execution. I will show you. So how we can analyze that output. So same thing, same code here. Just to go and debug, build the solution. So it's already built. Okay, just execute. So are you able to see the output on the screen? Cube. So are you able to see the cube?
Yes, sir. Yes, sir.
So what is the difference you are observing? So now I will show the difference step by step. That's why let's start from you people only. So just what is the third program output and fourth program output? What difference initially you are going to observe when after executing the program?
It was spinning and it is steady.
That is the initial difference, correct, right? Okay, good. So now what I have to do now? What I did in the previous case? I pressed either left button, right button or middle button, right? Correct, right?
Yes, sir.
Okay, now I am doing same thing. Now let's see whether it is spinning or not. I'm pressing left button, spinning. So are you able to see the change in the position? Sorry, not position, that spinning. So are you able to observe the spinning of the cube? So I am pressing left button, mouse left button. So this is about left side now. Now I will press right button. It's changed the direction now, right? It's changing the direction, right? It's changed it. See, if I stop, it will stop. It will not spin. But in the previous case, so whenever you are pressing the mouse button, left, right, or middle, so when you are pressing, it will be changing the position, but it will keep on spinning only. But this will not like that. If we are whenever you are pressing, till that it will spin and change the direction. If you start pressing, it will stop. It will be the what in whatever the position the cube is displaying, it will stop in that manner only. So there is no change. See, now I will start pressing the middle button. See, again it started spin. Now if I stop, it will stop. It will not spin. Okay. Again I will start left button. Again right button. Again middle button. Okay. So left, right, middle. So like this. And if I stop, it will stop. But your initial position will be something. Now after performing some iteration or some transformation, the position is different. Okay, so this is the observation. So we can say with respect to your third program. Okay, so that is one thing. And I told about this one keyboard interface, right? So like keyboard, now I'm pressing. So now I didn't do anything. Just now I'm taking the small letter X. Okay. So let's see. You observe. Is there any changes you can able to see? So are you seeing any difference? I'm pressing small letter X. Hello. Hello.
Yes, sir. Small ಆಗ್ಬಿಟ್ಟಿದೆ sir.
Small ಆಗ್ತಿದೆ ತಾನೆ. Small letter X use ಮಾಡ್ತಿದ್ದೀನಿ. ಅಲ್ಲಿ -1 ಅಂತ ಇದೆ. You remember? So we were of 0 here. ಕರೆಕ್ಟಾ? ಇದು ವರ್ಕ್ ಆಯ್ತು. ಓಕೆ, ಒಳಗಡೆ ಹೋಗ್ತಾ ಇದೆ, ವ್ಯಾಲ್ಯೂಸ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ನಾವು ಐ ವಿಲ್ ಗೋ ಟು ದ ಸೆಕೆಂಡ್ ಕೇಸ್ +x. So now I'll change +x. So let's see. So it will come back. How it went? Again same thing, it will come back. Got it? Again it's spinning and it will go like that. Okay, so like that it is going to work. Now suppose I'm taking now small letter y. Spinning. So again it is going, like, see. Now I'm taking capital letter Y. Like that. Now I'm taking small letter Z. Now capital letter Z. Now again I'm going to use my mouse to spin. If I stop, it will stop. If I start again with respect to any axis, either X or Z, it will start again spinning. Okay, if I leave, it will be stopping. So like this, these are the two changes you have to remember. So with respect to normal your parallel view and perspective viewing. So only slight change, either let's just only 4 to 5 lines newly we are adding in this program. That's it. Apart from that, everything same. Concept is also same. Just only the perspective viewing concept we are applying in this here. Okay. So just for clarification, I will execute that third program also once again. Just you look at here. We'll see. See, previously, just now we saw the fourth one. It's simply cube displayed. That's it. Is not spinning. Now I'm not doing anything. It's automatically started spinning. So now I'm changing again, pressing left button, again right button, again middle button. That's it. But keyboard I'm not using. So according to the question, we no need to use keyboard interface. Just we have to simple transformation techniques we have to apply for my cube. in order to spin with respect to x-axis, y-axis, z-axis. That's it. There is no change in that. Okay. So this is the third program, and that whatever we have seen just now previously, that will be the outcome of your fourth program. So like this, just you see the differences and you just understand. Just you can make it larger also. It will be reducing as your screen expanding. Obviously the speed also will reduces. It will take automatically the with respect to this screen whatever. So I have increased. This is the projection viewport. If I increase my viewport, automatically I told no, so values will be changing with respect to this width and height. It will change. For that even speed also affected by that. And these are the colors. I said the vertices will be identified with the different colors. So no vertices having same common color. You can observe different colors you can able to identify. See, and in between again your viewing volume will be filled with all the colors, all your RGB and CMY colors. So this is about your third program. Okay, so that's all about your third and fourth program. Okay, and this is about just modeling the color cube and apply simple transformation, and this is just moving the camera, and you're going to positioning the camera. According to that, you're going to observe the output. So this is about your last three classes. We have gone through the laboratory programs. Okay, we have done 1, 2, 3, 4th, 5th. So 1 to 5 done. 6 is pending. That is teapot. So that we will do later, not now. We will take after your second internal. And 7th also done, Sierpinski gasket tetrahedron program. And 8th we didn't do, that is Bezier curve. And 9th scan line we have done. So 9th also done. 1 to 5 we have done, and 7th and 9th we have done. Now left is 6th and 8th. That is one is teapot and another one is flag. So we have to construct teapot and flag. Indian flag, and we have to using this Bezier curve algorithm. So these two we'll discuss later. So now we have done with almost 75% of your laboratory programs. So that's why. So we are lagging in this. Just thought of covering your laboratory also parallelly. So I will stop for today's class for the lab session. So from next Thursday onwards, I will go back to my fourth module. We'll discuss fourth module. Okay. That's it. If anything, please you can discuss.